Welcome back, everyone. In the previous episode, we finished off reassembling the boat after we sprayed the new gel coat and coated the metallics with the grippy polyurethane material. Since all of the structural repairs have been addressed to the best of our ability without just getting new holes, we're going to go ahead and move on to some other new improvements. The first of which is going to be the rudders themselves. Since my boat is a 1979, I have the older rudder configuration. The easiest way to tell is the newer rudder configuration will have a slot on this top with a bolt, and instead of having just a circular pin, it'll have an actual plate. And the bolt that goes right here will allow you to slide that plate forward and backwards. Sliding it forward rakes the rudder towards the boat, and sliding it back rakes it away. So that's how you can trim your helm. And with helm trimming, there are two types of trimming. One is weather helm and the second is lee helm. And so we actually have a pretty bad weather helm right now, which is causing all of the force on the rudder. So if we take a look at the rudder angle, and I'll try and get as perpendicular as I can, but the rudder itself is raked backwards. In the true rudder position, it should be almost tucked up under here a little bit, but we don't want the rudder to be tucked too far under, otherwise that's how we get a lee helm. So we'll have to adjust the trim of these. Over here on the other rudder, I've already taken off the top cap so we could see what the rudder should look like. So right now the rudder is about at this position. We really want it tucked up and under, so that's going to reduce the amount of force it takes to pull the rudder from side to steer, as well as keeps us a proper helm trim. So ideally we want just a tad amount of weather helm, so if we do release pressure on the tiller, it will steer into the wind and start to leach wind off. And as you can see, I was messing around with these, and these are actually EPO rudders. So somebody had painted them black, the previous owner. So when we go through and do all of this recutting, we'll also probably sand this black paint off and refinish the rudders. In order to verify and mark the new hole pattern, we're going to be using a template for measuring the new rudder blades. So this is actually a single template for 16s, 14s, 18s, and waves all the way up to 21. So what you do with this template is you just cut it out and then fold it up on the proper lines to locate to the forward and top edge of the rudder, and then you can mark the location. There is a supplement sheet to show how it should be folded and how to properly align it. So I've already got it folded up, so we'll go ahead and take a look at our hole locations. So here's the template folded up. I did take scissors and cut that little hole out where our B location is. So if we look back at the sheet, for a Hobie 16 with the non-adjustable rudder cams, we're going to be doing BB. If you did have the adjustable cams, you would drill to AA. So since this is already cut out and we've got our holes there, we can go ahead and line it up to the forward edge and the top, and we're going to be on the left-hand side of this rudder blade. And then we'll just go ahead and mark off. The only thing I don't like about this method is it's not stiff. So you can't pull it hard or anything, because if you pull it hard, it's gonna start adjusting the box, but we want just a slight amount of contact on each surface to ensure that it's located properly. And then once we get that, we can take a silver Sharpie. I'm using silver because my rudders are black, so silver is nice and easy to see. So this shows us our new pin location. So as you can see here, the aft pin that connects to our tiller assembly is pretty far back, and our rudder pin that connects to our casting is really far up. So we're gonna go ahead and pop fill all of these holes on both rudders, and then we'll go ahead and just do one last locating of these before we drill them out. Before we do any sort of bonding prep, we first need to make sure these holes are nice and clean. So per usual, we're just gonna do that with a little bit of isopropyl alcohol. All right, rather than working hard, let's just use a bottle brush. Wipe this surface clean one more time. All right, now we'll let the IPA flash off and we'll tape this side up. Now that the holes are blocked off on this other side, we're gonna go ahead and mix up the epoxy. Once it's thoroughly mixed, I'll start cutting fibers in until it's pretty thickened up with fibers. And this is just a single twill of carbon sheet that I had laying around. So if you don't have single uni like this, then you can just get, you know, either milled carbon, milled fiberglass, or something else to stiffen it. We just don't want only epoxy, otherwise it'll crack out. So let's go ahead and mix and start cutting off some of these strands into the epoxy. The epoxy and carbon is cured now. It's been at least a week, but I came through and checked it. So this is the excess we had left over. It's rock solid. Even this like thin little loop is very hard. So this all looks really good. There doesn't seem to be any air bubbles or anything. Since we put that tape over top with that little square tape dot, we didn't get any push out that is in excess, so this opposite side should be really easy to clean up. Then once we clean up both sides, we'll probably just go straight into drilling the new holes. So drilling the new holes will allow us to do the fit check. Once the fit check is good, then we'll go through and remove all of this old black stuff. All right, so we've got 120 on the sander and we've got it hooked up to the vacuum. Ideally, we'll vacuum all the carbon dust away. In reality, that's not the case, so I will still wear my respirator. Now that we at least have these sanded smooth, there is some touch-up work that we're gonna have to do, but first we're gonna go ahead and mark the locations of the holes we need to drill, so then we can start drilling them and test fitting them. So to do that, same way we marked it before, we're gonna use the template, make sure that the template is nice and squared up, and then we will mark through the holes we had previously marked. And so that looks about where we were previously, which is a good thing. The next step is going to be to drill. So we'll start off with a 3/32 drill bit and then go about 1/4 of an inch deep. And so we'll go ahead, same way, step all the way up, only going about 1/4 of an inch deep to go ahead and test fit the rudders into the castings to make sure they're in the correct location. So you can see there's a core in here. You can see the different layers of the carbon as well as the core. So we'll go ahead and fit this up over at the rudders. It's 2 days past when I first drilled the rudders. I've had some time to do some research and take a look at them a little bit more closely. And pretty much what I found out is that the rudders are drilled in the right spot. So let's go ahead and take a look at them, and then we'll talk about item number 2. So first off, looking at the rudders, obviously the left-hand rudder is still not engaged properly. That's because it's too thick, so we'll sand that thinner. Before this right-hand rudder, this one is now engaged properly. There's a little bit of a skew here, but the rudder is raked a lot further forward than it was previously. I want to show you what the issue was up here. So when we pop it up, you can see that this cam is engaged in the downward position, and that's what was causing the issue. So when we try and lower this back down, we're getting the bar interfering on the cam. So actually what we need to do is take a screwdriver and push the tension down to flip the cam up. So when the cam is in this position, this is the position the cam needs to be in to lock the rudders into the right place when we're going forward. We'll need to clean up some slop in the rudder, but this cam should move freely like this. And what's gonna happen is this metal rod here is gonna come down and it's going to engage the cam, rotating the cam and locking it into position. So my cam is actually over rotating, and if I adjust it a little bit, it pops right down in. And so now the rudders are nice and locked in, and when we disengage, the cam pops back up this way. What we need the cam to do though is fully rotate back up. So next time I pull these rudders apart, we're going to pull that whole assembly out. Then we're gonna go ahead and replace this cam as well. But the rudders themselves are in the right position when we actually lock it down. So we're gonna go ahead and transfer the holes through all the way. All right, so the rudder is swinging well, but whenever we try to engage it, it's getting caught because the rudder is too thick compared to this upper casting. So let's go ahead and take a look at what that looks like. But the issue we're seeing is that when we measure these, this rudder is 1 inch 60 thou, 1 inch 10 thou, and the casting in here is like 1 inch 9 thou, 1 inch 10 thou as well. So the rudder is too thick for this inside of the casting. I don't know how this was on here before, but there's a fitment issue between the two.
103, 102. So we did get this down quite a bit. I did tested it up, and you can see the upper casting did mar the surface a little bit. So I'm not going to grind anymore on this if I don't have to. So I'm going to check out the corner or the upper casting.
So we fixed the sticking issue on this left-hand rudder. As you can see in here, I've taken a file to this inside corner where it looks like it was dented at one point and material was kind of bent over. So by coming in here with just a small little file and filing that back smooth to the inside of the casting has worked really well. Our rudder engages properly. And we can see it's a lot better rake forward than it was previously. So now we're nice and locked in. So what we'll go ahead and do is finish sanding all this black paint off of the rudders, and then we'll start working on the cams. Since this does stick, it doesn't want to rotate back, we'll go ahead and take the whole cam structure apart, re-grease this little piece in here, and then I actually 3D printed new cams that we'll put in here and see how those work.
The sanding is pretty boring to watch, so we'll just skip over most of it. Pretty much what I'm doing is just sanding all of the black paint off and getting down to a nice, good composite surface that we can go ahead and hot coat over top of to protect it and make the rudders look really nice. We're going to start by wiping down with isopropyl alcohol one last time before we get ready for a hot coat. Hot coats are pretty straightforward. Primarily what we're trying to do is just put a thin layer of epoxy over the entire surface. You will see that I get out a bottle brush to try and put some of that epoxy down into the rudder holes. We'll definitely have to come back through in the future and just ream those holes back out, but that'll make sure that the core is sealed properly in there and that there's no water intrusion. The big goal here is to minimize the amount of air bubbles and get a smooth surface so that way our sanding post hot coat is easier.
Alright, so the last time didn't work out so well. We had a lot of runs onto this other side. You can see where I've sanded them out. In conjunction with that, my sander has been on the fritz, so it was really difficult to actually sand these pieces out. I had to do a lot of it by hand. Since that side didn't look good either, we're instead gonna apply it with a paintbrush, and hopefully we can get a better surface when we come back through and hit it with the heat gun. As you can probably see from this angle, there are a lot of bubbles in here still. So this is the downside of using a paintbrush. So we tried with the heat gun, we got as much as we could. I'll let this start to tack up a little bit and then I'll hit it again. Hopefully that will like lock the bubbles in place a little bit more, but not all the way. And then we can hit it with a heat gun and make those all pop. So we'll probably come back in like 10 minutes and see what we can do.
All right, what a difference a couple hours can make, going from all of these bubbles and inconsistent surfaces, different thicknesses, to a 320 grit sand. It's smooth. You can't see as many of all of those defects. So this is where we're gonna leave it, and we'll just make sure everything fits up properly. In order to install all of the rudder tensioning hardware, we are going to use some marine grease. The thought here is that, one, it's going to help everything move fluidly and ideally help keep some of the water out. If we do get some water, we do have this drain hole, so hopefully it drains through and doesn't just clog anything up. But we'll go ahead and dip one side of the spring into the marine grease, spread it around on the top of this plunger, and put it through the bottom of the corner casting, and then hit the bottom of it with the tension screw. We'll probably only go in a couple threads to start with until we can install the cam completely, get the cam locked down, and then we can tighten up the tensioning screw to ensure we get proper rudder tension. We might have to play with that a little bit once we get the rudders actually on. But we'll go ahead and start off with some marine grease, and this is gonna get kind of gross and dirty. All right, so this is all greased up. We're gonna insert it from the bottom. The grease is also gonna help it keep in place while we follow it up with the screw. So now we're gonna position the cam in. We will push down until that lines up completely, and then line it up with the other side. We'll take the other countersunk screw, so this screw is actually really long. We could probably reduce it if we wanted to, but now we lock in and lock out a lot easier. So we can adjust that tension as necessary. We've got the rudders here. They are sanded up to 320 grit. They're nice and smooth. I've got them marked left hand and right hand, so that way I know which is which, because the upper castings fit differently. So we chase these holes, the bolt slips through perfectly. So we will go ahead and install them into the rudder.
So the rudder assembly is finished, but I've taken the boat out a couple of times now, and there's one issue with the rudders, and that's that the tension on the spring for the cam is not high enough. So while it locks in place, you can see right there, it's pretty easy to pull up. Right there, it's locked in. But the problem is when you're going underway, the pressure on this rudder just pops it up. So to fix it, we need to be able to tighten that screw that tensions the rudder cam in further. Since I 3D printed them, they're not threading in super easily. So to fix that, I've got a 3/4 by 10 NC tap. So I'm chucking it up in a number 13 12 point socket. It has to be divisible by 4, so that way the square can fit in there and lock in. We're also using a 6-inch extension in order to get into the casting from one and or both sides to go ahead and chase those threads up and make sure that any sort of corrosion that's built up over the past years is cleaned out, so then we can reinsert that screw and properly tension the rudder. So as you can see, these were the longer screws that I had made, and they're sticking out quite a ways. So I did make some shorter ones. We'll go ahead and see, once we take these out, what the threads look like to see if we need to swap out these other ones. So with these new screws, we're just gonna slide it on our screwdriver, get it kind of lined up, back it in until we feel it drop into the threads. So like if you see it, and then it'll drop. And then we just tighten it in. I'm just going 2-3 threads in. So it looks kind of like that. And then from this top side, we'll just go ahead and drop the plunger in. So that way it's not too high up. And I broke a cam. That's great. I do have one other cam, since this guy's a little bit broken now. Since this is a new cam, I'm gonna break my little L on the back, so that way I know it's locked. And we'll test this one out the same way. We'll pull from the bottom of this. Alright, that does need to be tightened. So again, I'm only gonna go half a turn at a time. I'll probably try it out, see how it goes. In the meantime, I'm gonna start a couple more cams printing just to make sure I have extras while I like tweak everything out. That's the nice part about the 3D printer and printing my own cams, is that if I do break one, it's pretty easy to replace and I'm not having to spend 20-30 bucks each time.
Thanks for joining me on this phase of the project, and we'll see you in the next one.
Woo, got a little gust.